Go ahead and let me know if you can hear me talking. Okay, one of you said that you could see me, but you could not hear me. Okay, we are just going to wait. Someone is having a hard time hearing me, hopefully. Hopefully she will come back in a second. We are in week 3 of marine biology. I'm very excited. This is the week where we are going to talk about convexes, which are cartilaginous fish. It looks like, Mallory, your microphone is not connected, or your web camera. So that probably is why you do not see the talk button. The rest of you should see it in the same spot. Braden, we have 9 weeks of class. So this will be a third of the way done. I must say that I am super impressed with the homework assignments that I got from you guys. I think I got them from everyone that's here right now. If for whatever reason you didn't get a chance to either send it to me, it wouldn't send, whatever the reason is, you can still certainly submit them. I love looking at them. I haven't graded them yet because I want you guys to go ahead and share them with us today. So you will get a grade, but there is no grade there quite yet. So let's take a look at our whiteboard. Victoria, if your headphones aren't working, you may want to just jiggle the plug a little bit and see if the microphone works then, or unplug it and then plug it back in. I'm hoping Victoria can hear us now and is all set. Yeah, sometimes just unplug it and plug it back in. It could just be a bad connection. I don't know how to explain it. So the picture up here Okay, Mallory, you could check yours by going to the wrench on the bottom left-hand side of your screen, clicking the button, clicking the wrench, clicking microphone setup, and making sure that you have the correct microphone selected. Okay, so let's go ahead and get started. The picture up here is a whale shark. You guys made some great observations. Whether or not you knew it was a whale shark doesn't make a difference. Okay, your observation, the fish has white spots on it. Fantastic. I see a type of shark. Lizzie, you are correct. This is a shark. It's bluish grayish on the back and has a little bit of black on its back. There is a diver in it. Good job. Now the fact that there are 2 different things in here, a diver and the shark, you can tell size. You can guess that the diver is probably somewhere between 5.5 and 6 feet tall, just because that's where the average person would fall. So the whale shark is obviously way larger than that. Okay, so Braden's observation that it is big is a great observation in this case. It is a whale shark, it is the biggest shark, it has white spots, and it eats tiny krill. Perfect. Just another little practice of our observation skills. So what we are going to start with today is we are going to start by thinking about our bony fish we talked about last week. Now, last week we talked about osteichthyes, or bony fish. In the box I just drew on the whiteboard, go ahead and come up with some bony fish, either examples of bony fish or some characteristics, some descriptions. So, for example, I may write up here, they have gills. I may write that the swordfish is an example. Okay, so go ahead and put some information up here for me, either that you remember from last week about bony fish or that you learned by doing your fish portfolio. Okay, see if you can think of anything that would go in this box. Any characteristics, any examples. Okay, seems like we're a little bit stuck here. So let's take a look. Haley wrote the giant frogfish. That is an example of a bony fish. They have anal fins, correct. They have gills. The swordfish is an example. They have scales, would be another one. They live in the ocean, you could have put up here. Anything we talked about last week. They have paired fins, how they have the lateral lines. All of those are examples of bony fish. Now what we're going to do today first is we are going to share the fish pamphlets that you guys turned in to me last week. Now I am going to start with one about swordfish. So whoever this is, you get to go first. Now what I'm looking for is not anything fancy. All I'm looking for you to do is tell us a little bit about your fish that you chose. Okay, let me just make this one smaller so we can share it. Now, I got all different sorts of pamphlets. I had some typed pamphlets. I had some handwritten pamphlets. Okay, whose was the swordfish? I don't have a name written right here. All right, Brayden, go ahead. Why don't you share with us the information you learned about swordfish?
The important facts that I learned were that they slice through the water 60 miles per hour. They have scales, but they don't have pelvic fins. They can weigh up to 1,000 pounds. They're hunting. How they hunt, it kills and stuns its prey by splashing about with its sword. The keys is it's 7 feet long, mostly by long sword. Some can grow up to 12 feet long, and the fish is a fast swimmer because it can slice through the water. The habitat it lives in is tropical and temperate waters around the world, and the behavior of the swordfish is they don't travel with a school. They like to be alone.
All right, great job, Brayden. Very nice. This was a nicely done report. It had all of the information that I asked you guys to find out for me about swordfish. Great. Okay, next we are going to go up to where we usually look at PowerPoint. And Mallory, yours is going to be next. Oh boy. Now, Mallory did a great job. Instead of a osteichthyes, or instead of a bony fish, she did a stingray, which is actually one of the animals we are going to talk about today. So great job, Mallory. Why don't you go ahead and share some information about the stingray with us? Make sure you click the talk button, Mallory, at the bottom of your screen. Okay, I think Mallory must be having problems with your microphone because I can't hear you. So what I want you guys to do is I'm just going to point out a couple of neat facts about the stingray that she put up here. She has a picture of a stingray up here. Okay, now I thought one of the neat facts we'll leave my camera off for a minute. Make your PowerPoint screen larger. Don't worry about looking at my frozen screen right now. One of the neat facts that she had up here was that the lifespan of a stingray is 15 to 25 years. That stingrays are edible. I thought that was a very neat fact. Okay, she also had up here, very good, Mallory, stingrays are fish, they are not mammals. Very good. She also had up here that they can be very aggressive, which I did not know. So great job, Mallory. Next we have Elizabeth. Now Elizabeth did a butterfly fish. Would you like to share yours with us? Okay, Lizzie, would you like to share? Make sure you hold the talk button down. Okay, her microphone's not working either. It seems like there's a lot of feedback with it. So I'll go ahead and share hers with you. She did butterfly fish, and she included a couple of neat pictures here. Some facts that I was not aware of is that they have long, pointed noses to help them reach into the cracks to eat. Many have a black stripe along their eye. And butterfly fish like to be in small groups, but some also live by themselves. They are active in the day, and they feed on algae, worms, and zooplankton. Very nice. The next one that we have, and I don't have the name written here either, is the Royal Grandma Basslet. Whose was this? Jamie, would you like to go ahead and share it with us? All right, I will go ahead and share it for you then. We have the Royal Gamma Basslet is a beautiful fish that is purple in the front of the body but yellow in the back. It has a little black spot in the front of its dorsal fin and a black line that streaks through his eye. The middle section of the fish can have either a sort of white area or an orange area. The Royal Gamma is also known as the fairy basslet. It resembles the false grandma, but the difference is the false one has a clear fin and does not fade. The Royal Grandma is a planktivore. It mostly eats zooplankton and crustaceans. It also is a cleaner fish. It removes parasites from fish and learns to eat dead wood. They live in the Bahamas, Venezuela, Lesser Antilles, Bermuda, and through the waters of Central America and the northern parts of South America. They can be very territorial. All right, next we are going to go ahead to the frogfish. And this, I believe, was Haley's. Haley, would you like to share your frogfish with us?
The frogfish is found in tropical waters of Asia, and they will blend in with the coral that they live in, and when a prey fish comes close enough, it will suck it up. They use their flippers to walk on the bottom of the ocean, and has flesh-like lure to lure in the prey. And they can lay between 40,000 to 180,000 eggs.
Great job. And for those of you who aren't quite sure what a giant frogfish looks like, there it is right to the right-hand side. Perfect job. Thank you very much, Haley. All right, and Victoria has hers. She is going to share her video with us. So what you're going to do, Victoria, is underneath where my picture normally is, there should be a question that asks you if you would like to share your video. Go ahead and click yes. And hopefully it will come through. Oh, here it comes. All right. Here we go. It's all yours, Victoria. Make sure you turn your mic on.
Okay, so I did the mud skipper. Camera. I drew a picture of them. It's hard to see because it's all in pencil. And then I wrote for this that the mud skippers generally live in mangroves, nipper palms, and tidal mudflaps. And depending on the species of the mud skipper, it can be found in fresh, brackish, or marine waters, including swamps, marshes, or tide pools. And these fish are carnivorous, and they eat small animals, including insects, crustaceans, and worms. And to get their food, they sit motionless for part of the day in the mud looking for prey. And once they spot a creature, they use their strong shoulder fins to chase the creatures across the water into the mud. Right there is what another picture is with them sitting in the water. And then the mud skippers are torpedo-shaped goobies with muscular arm-like pectoral fins that function as legs. And when on land, they also have two dorsal fins, and depending on the species, their anal fin can be joined to form a sucker that allows them to climb trees and that type of stuff. And because water does not flow through their burrows, mud skippers' homes are normally very low in oxygen, so they repeatedly gulp oxygen and release it inside of their burrow. This behavior lets them stay in their burrow for up to 30 minutes and provides oxygen for any developing eggs. Also, to see above water, mud skippers pop their movable eyes out of the water to see like a submarine. The mud skipper's eyes work independently of each other when swimming. They can keep their eyes above water so that they get a 360 degrees view. Some facts about the mud skipper is that they excavate its burrow by scooping out mud with its mouth and spitting it on the edge of its burrow, creating a wall. Also, they mostly live on land, which is very weird for a fish. I found that super interesting that they mostly lived on land. And the most interesting fact, in my opinion, is that they can climb trees, well, depending on the species, but they can climb. And to conclude, I think mud skippers are super interesting, and if you want to know more, you should do research on it.
All right, great job. Thank you very much for sharing as well, Victoria. All right, I am going to try my camera one last time here. So is my video working now? Hopefully it is. Hopefully it's not frozen. Anyone, can you respond in the text chat? Awesome. Okay, so, perfect. We are going to talk today. Oh, Victoria says no. All right, hopefully, we'll give it a second, Victoria. Hopefully it'll click in on yours. Okay, perfect. Okay, today we are going to talk about chondrichthyes. Last week we talked about bony fish. Today we are going to talk about cartilaginous fish. Now what I'd like you all to do is take your finger and touch your ear. You may need to move your microphone. Take your finger, touch the tip of your nose. Those are parts on your body that are cartilaginous or made out of cartilage. That is what the entire skeleton of a shark, skate, ray, and ratfish is made out of. Now, last week we talked about fish with bones or bony fish. This week we are going to talk about fish with cartilage or cartilaginous fish. So a chondrichthyes is a fish with a jaw, cartilaginous fish composed of sharks, skates, and rays. Those are the three main types. They don't have a skeleton made up of bones. They have a skeleton made up of cartilage. Cartilage is strong enough that it allows the body to be rigid and to have a shape, but it's also a little bit bendier than bone. Chondrichthyes or cartilaginous fish have existed on the earth for over 400 million years. Most of them are ectothermic, which means they have body temperatures similar to the temperature of the water around them. So let's take a look at some examples. Here are the four main groups. We have sharks and ratfish. Shark is at the top. Most of you know what a shark looks like. I don't think very many of you are going to confuse a shark for any other type of fish, at least most sharks. The bottom is a ratfish. They're not very common. We're not going to spend a lot of time talking about them today. This is actually the only time you'll hear me talk about them. On the right-hand side, you have skates and rays. Skates and rays are two different types of animals. A skate is at the top here, and the ray is at the bottom. Even though they look similar, there are some very big differences between the two. First, we're going to talk about sharks. Now, sharks have teeth-like scales called denticles. Last week, we looked at scales of bony fish. This week, we are going to take a look at the denticles of a shark. Another characteristic of a shark is their mouth is usually located ventrally. All that means is their mouth is on the bottom of their body. It's a fancy way to say it. They were the first fish to have paired fins. They have both paired pectoral and paired pelvic fins. And this allows them to be more efficient swimmers. They have 5 to 7 gill slits per side, and they have no swim bladder. Now, last week, we didn't get a chance to talk about a swim bladder when we talked about our bony fish, but a swim bladder is something sort of like a balloon in a bony fish that helps the fish stay up towards the surface or down towards the bottom. Sharks or cartilaginous fish do not have this. Now, the largest shark in the world is the shark that I just showed you at the beginning of class, a whale shark. The whale shark, is a plankton feeder, which means it eats the tiny microscopic plankton in the water. Here's a picture of a shark. Now, the shark has an eye, where you would expect it. Sharks have a spiracle, which we'll talk about in a minute. Sharks have gill slits on either side of their body. And sharks have a lateral line. The lateral line on a shark serves the same purpose as the lateral line on a bony fish. Now, this is a picture of the denticles of a shark. These are the scales. This is the outer edge of a shark. In this picture, the shark's head would be to the left-hand side of your screen, and his tail would be to the right. Go ahead and raise your hand if you have ever felt the skin of either a live shark or of like dead shark skin that you might find at an aquarium. Go ahead and raise your hand. All right, a bunch of you. Great. Would anyone like to share with us how the shark skin feels? Haley, would you like to share with us how that shark skin felt? All right, go ahead. Just hit the talk button on your screen, Haley.
It feels rough and scratchy.
Okay, it definitely feels rough, and it feels more rough if you move from the tail towards the head. If you move from the head to the tail, it actually feels quite smooth, almost like a leather, or like if you have a dog or a cat, the bottom of their paws. That's because all of the denticles are facing in the same direction. So let's take a look at this next slide. This next slide is a more microscopic picture. Oh, Brayden, I'm sorry. She said that it feels rough. These are a more microscopic picture of the denticles of shark skin. So let's take a little bit of a closer look. The denticles of a shark's skin seems to have little ridges on it. Any idea what these ridges could do to help a shark? Raise your hand if you have a guess. What do you think the ridges could do? Mallory, go ahead.
They can protect the shark.
Awesome. They certainly are used to protect the shark. Good job. Anyone have any other guesses? There are a few other things. Victoria, go ahead.
They're used to scratch maybe other sharks. Maybe?
They certainly can be used for protection, yeah. The other thing is these denticles have little ridges on them, and that allows the water to move more quickly over the side of the shark and allows the shark to swim faster. Great ideas, ladies. So a shark has lots of senses. Some senses the shark uses more than others. Sharks have a sense of sound or a sense of hearing. They have a sense of smell. They have a sense of sight. They have an electromagnetic field sense, which is a sense we as humans don't have. And they have a sense of touch. Would anyone like to read this slide for me about the hearing of a shark? Go ahead, Brayden.
Sound travels 5 times faster in water than air and quite far. Sharks have inner ears but not outer ears. They are attracted most by low-pitched sounds. Sharks cannot make any noises. They have no vocal cords. Bursts of sound like that made by injured fish are particularly attractive. This is also the sound made by humans splashing in the water.
Very good. So some scientists theorize that the reason sharks sometimes attack humans is because they're splashing around in the water and they're mistaken for an injured fish or an injured seal, which is the normal food source of a shark. How about the sense of smell? Would anyone like to read about their sense of smell? Go ahead, Mallory.
Will then help the shark to move closer to the prey through its nostrils. Sharks can detect 1 part of blood in many millions of parts of water. 1 part per million is equivalent to you taking 1 large mouthful of food compared to all the large mouthfuls you take in a lifetime.
Thank you. So what that means is, let's pretend you had scrambled eggs for breakfast today. You took a bite of your scrambled egg, and you decided, I don't like scrambled eggs. That was the only biteful of scrambled eggs you will ever take in your entire life. You'll continue to eat normally, but that was the only time you'll ever eat scrambled eggs. That amount of food you took this morning and compared to all of the food you will eat is all it takes for a shark to be able to smell blood in the water or sense blood in the water. They have a super good sense of smell. Now their sense of sight, not so good. Yes, that was a picture of blood in the tube, Mallory. Shark's sense of sight, not so good. They can see well in dim light, but not so much in bright light. What they can do is they can change the shape and size of their retinas to allow more or less light through. And some sharks have something called a nictitating membrane that can cover their eye completely to protect it while it is eating. So when a shark grabs onto a prey, this little eyelid on the bottom looks like it's a little gray, milky white covering part of his eye here. That comes up, goes over his eye so he does not hurt his eye in his fight. Another thing that sharks have is they have a sense of electromagnetic fields. Now, electromagnetic fields are produced by prey and can be detected by sharks. This special spot on a shark is called the ampullae of Lorenzini. The ampullae of Lorenzini are electroreceptors located on the snout of a shark. It allows them to detect weak electrical currents produced by a prey or a fish's gill movement. This picture shows you where the ampullae of Lorenzini is located on a shark. You can see his eye and his nose and the start of his mouth. Those little black polka dots on his snout are the ampullae of Lorenzini. Sharks can feel touch with their skin, and they can also taste using taste buds in the lining of their mouth. Okay, so we are going to go ahead and, most do not, Mallory. We are going to go ahead and look at my camera. What I'd like you to do is, if you can, make my camera large, and I'm going to show you guys a couple of things. Now, one of the things my family likes to do is look for shark's teeth. So we go to South Carolina, to Myrtle Beach for vacation every year. And every year my kids come back with a whole bunch of shark's teeth that they have collected. Oh. All right, so go ahead and answer this for me. Go ahead and let me know if you can hear me talking. Lizzie says she's having a hard time. It may be the internet on your end, Lizzie. Typically, the camera will freeze sometimes, but normally the volume does not go on my end. Okay, so I'm going to move my screen, and I'm going to show you some of the teeth that my kids have collected. All right, I went ahead and I put a pencil in it so you would be able to get an idea for the size, and then this is my pinky. Sharks' teeth are very unique. These are only a few different shapes of teeth and colors. The colors of sharks' teeth can range from pure white to brown, gray, dark black, and everything in between. If we look at these teeth, we're going to start with this black one on the edge. If you start here and you notice this tooth has very pronounced serrations or jagged points along the edge. That tooth, the right and the left side, is lined with these serrations, which makes it good for tearing through meat, just like your knife would tear through a steak or a piece of chicken or whatever you're eating for dinner. This type of tooth is for tearing meat. The next tooth has some smaller serrations on the side of it, but not so much. It's a little bit pointier, so maybe it can hold prey a little bit better. This first tooth is used to eat mostly dead prey. Now if we go to the other side over here, we can see a very clear distinction between the actual tooth down here and the gum. The gum of this tooth is brown and the tooth is mostly white. And over here we have a very pointy tooth with no serrations on its side. That's mostly gray. Now the color of the shark tooth is determined by how it was fossilized. It has nothing to do with what shark it came out of. The shape of the tooth helps you determine which shark it came out of, but the color is purely how quickly and where it was fossilized in the ocean. So those are teeth that we as a family have collected. Now I'm going to show you a tooth that my son purchased. All right, this is a huge tooth. If you can tell, I'll put my pinky back in the picture so you can compare it. This is a tooth of a megalodon shark, an extinct shark that measures about 6¼ inches. When you measure a shark's tooth, you measure from the tip of the tooth to the top of the gum in a straight line. This one, like I said, is about 6¼ inches. Now, to me, it's not a whole tooth. Okay, when it was fossilized, part of it broke off, or part of it broke off at some point between being fossilized and when he purchased it. But this tooth does have the little serrations along the sides. It's a good example of a tooth that's lost its enamel. Down here, this lighter brown is the enamel of the tooth, just like your tooth has enamel, and it can be damaged, just like your tooth can, and some of the enamel be lost. Now, an advantage that sharks have, I'm going to switch it here, over humans is what in terms of teeth? You get 2 teeth. You get a baby tooth and you get an adult tooth. If you lose your adult tooth because it gets knocked out of your mouth, tough. There's nothing there. What's unique to sharks? What do they have in their mouth that's a little bit unique? Victoria, go ahead.
If they lose a tooth, I'm pretty sure it grows back. And also, they have 2 layers of teeth.
Perfect. A shark has more than 2. A shark has multiple layers of teeth. So let's pretend that this was my shark's mouth. I'm a shark. Here's my mouth. We're going to pretend all of these teeth look the same. I would have 3 layers of teeth in my mouth, and if I lose one, no big deal. The next one comes right up. It comes back in about 24 hours. What would an advantage to a shark be that his tooth comes back so quickly? Let's pretend I'm a shark. I'm fighting and I'm trying to eat a tuna, whatever I'm eating. I'm trying to eat a sea turtle. I bite into that sea turtle shell and I lose 8 of my front teeth in its shell. They get stuck for whatever reason. I can't get them out. They fall out of my mouth. I'm now missing 8 teeth right in the... Could that be a problem? Yeah. It would be a big problem. The advantage to my teeth growing back in about 24 hours is that I then could protect myself. I would have to hide out for about 24 hours, but after that, I would be all set. Now this shark that this came out of, the megalodon shark, they think was big enough that it actually ate prey the size of small cars. So it certainly is a shark that I would not want to see scuba diving. Okay, if you look, like if I hold it up next to my head, it's pretty big. All right, so let's take a look at skates and rays. Skates and rays don't have teeth like sharks. They have bony plates in their mouth. In their mouth, their bony plates kind of are more like my finger. They're hard, and they actually are bony, and they're just lining their mouth. They don't have any sort of serration on them to chew or to cut with. So go ahead and look back at your PowerPoint. Skates and rays are characterized by having flat bodies. Their pectoral fins, which are their side fins, are flat and extend out and appear almost like wings. But they're not. They're actually the fins of the animal. Most skates and rays are demersal, which means they're bottom-dwelling animals. They have 5 pairs of gill slits. If you look at the picture at the top here, this is the underside of a skate. It's white, and you can see the little gill slits in it. In skates and rays, there is no natural distinction between the body, the head, and the pectoral fins. Everything is kind of blended together. And the eyes of a skate or a ray are on their dorsal side, which is the top. Many skates and rays bury themselves under the sand, becoming almost invisible, except for their protruding, watchful eyes looking out. If you look at both of these pictures, you can see just their eyes and their tails sticking out. Go ahead, Mallory.
How can you get that picture without getting hurt or ill or sick?
Well, I certainly wasn't the one taking the picture, but a lot of times divers can get pictures of skates and rays and other animals at a safe distance away and just using super duper zoom lenses. Sometimes they'll go in cages to separate themselves from the animals, but most times, especially skates and rays, they're not going to try to come get you. They're scared of you, so when they notice you're there, they're going to go away. That was a good question. So that kind of leads into our next question. What is the difference between a skate and a ray? One of them is dangerous, and one of them is not. A skate can be between 1 to 6.5 feet long. They have a very slender tail that they use as a rudder. And some have electric organs to help locate prey. They live in sandy and muddy bottoms, along shores, or in deep water, depending on the species. And they have a caudal fin on their tail. Now, skates have no stinging spine on their tail. So a skate is not dangerous to you at all. They will not bite you. They will not sting you. They are generally smaller than rays. Here's a picture of a skate. Oh, and Haley just wrote that she has almost been stung by a stingray and has caught a stingray. Stingrays are definitely a fish that gets caught often. Most people do not try to catch stingray. They're called bycatch. But they definitely can be caught. Most stingrays have a whip-like tail with a stinging spine for defense. They have a poison venom gland at the base of the spine, and they stick their spine into something. It may cause serious injury if you get it in the foot or the hand, but if it stings you in the abdomen or the chest, you could end up dying from it. I'll ask one question. 1 second, Victoria. What the stingray spine looks like is it's pointed, and it has little serrations on the edge, sort of like a knife or a fish hook barb. And when they go in, it doesn't hurt, but as you're pulling the spine out, it hurts. Go ahead, Victoria.
So if at an aquarium they say touch a stingray, would that be I was touching the other one, I don't know what it's called. I forgot what it's called. The straight or whatever. Or would I have been touching a ray?
That's a great question. Without actually seeing it, it's hard to tell, but chances are if you were at an aquarium and they told you you were touching stingrays, you were probably touching stingrays that had their spines clipped. What they do at aquariums, like at SeaWorld down in Florida, I know they do. Right, and she asked what if she was told she was touching a stingray at an aquarium. Was she really touching a stingray, or was she touching a skate? And I said chances are you were touching a stingray if it was at an aquarium. They generally are honest and upfront. But what they can do is they can clip with what looks like nail clippers. They can clip the spines off of stingrays so that they can't harm you. That is pretty cool. So a stingray is generally larger than a skate. Some stingrays can grow up to 750 pounds. And here's a picture of a stingray. And here's a picture of a very large stingray called a manta ray. Now what I'd like you guys to do is flip back to our whiteboard, and I'm going to unlock them. And we are going to do something called a Venn diagram. Hopefully, you know what that is. A Venn diagram is where we can compare two things. We are going to compare bony fish that we talked about last week with cartilaginous fish. The way you work a Venn diagram is that if it is a characteristic of just a bony fish, you are going to place it in the area that's highlighted yellow. If it is a characteristic of just a cartilaginous fish, you are going to do it in the area that's highlighted blue. Okay, guys, don't highlight, please. If it is a characteristic of both, you are going to put it in the area highlighted green. So for example, both cartilaginous fish and bony fish have gills. So I'm going to put them there. Only bony fish have bones. So I'm going to put that here. Okay, go ahead and add whatever you add or examples of either bony or cartilaginous fish to this diagram. Go ahead, Victoria.
So there are different types of sharks. I know that there's a lot smaller sharks, and I might think they're a fish. Would I put maybe sharks in both because maybe it's more of it does have bones?
That's a good question, but all sharks have cartilage, not bones. So any sort of shark would be under the cartilaginous fish side. The smallest shark is actually called a dwarf shark, and it's about 8 inches long. So to kind of give you an idea, a dollar bill is 6 inches. So it's just a little bit larger than a dollar bill. That's a great question. You guys can put examples of either cartilaginous or bony fish. You could put characteristics. I'm going to give you one more minute. Go ahead, Mallory.
What is the smallest shark called?
The smallest shark is called a dwarf shark.
How big can it get up to?
They can get up to be about 8 inches, so they are very, very small. There you guys have some great examples up here. You have for the bony fish bone. They have just bones, no cartilage. I'm going to put some examples up there. I'm going to put last week we watched a video on swordfish. Oh, someone's putting sailfish. There's sunfish. There's bass. There are frogfish, mud skippers. Those are all examples. Dolphinfish or dorado, good job. Both can have teeth, very good. They both have gills. I'm going to put up here, they both have a dorsal fin. They both have paired fins. They both live in the water. Okay, and on the other side we have stingrays and sharks. We have just cartilage, made of cartilage. The dwarf shark is 8 inches. We have sharks are cartilaginous. Oh boy, our circle went crazy. Let's see if we can move it here. All right, and on that note, we are going to say goodbye for the week and leave our crazy Venn diagram that looks silly now. Your homework is up in Moodle. Your homework is much easier this week. It is an article about shark's teeth. It will be up and ready for you to go in about an hour. I just have to change a couple things in it. I hope you guys had a great week, and I will see you all next week.